Hello guys. Today we're gonna touch base on 3 point grade 9 geometry, 3.10 section 3.10, and that is the learning target is basically this two. Use perpendicular lines to find the distance between a point and a line. Alright. And find the distance between parallel lines using perpendicular distance. So there are two examples that we will go through today. Um, so let's start from the first statement. So when we have a point and a line, let's call it AB. This point can have all different distance, but that's the shortest distance from point to hit the line AB. It will be perpendicular. This line, the blue line, will be perpendicular. All right. So to line AB. Essentially, that's that. What this statement is. The rest, I don't think is important, and we will go through example one first. Example one first. Okay, example one, we have we're trying to determine the distance, the distance from here to here. All right. They are the formula that we will need. Formula that we will need. Let's put it here. Formula. Of course, we will be using slope, which is y2 minus y1, x2 minus x1. Second formula, we learned it from last section. M equal mx plus c. C is y-intercept. X is x, y is y, m is slope. Another formula that we will be using and is not appearing previously is y minus y1 equal m times x minus x1. We will also be using m1 times m2 equal -1 because this is perpendicular. All right. You can see here this we need this when we have two coordinates. We need this when we have one slope and and one y-intercept. And for this equation, we need one slope and one coordinate. Okay, sometimes we will have more than one, you just need to use one of them. And because we are looking for the distance, we should also need this. Okay, y2 minus y1 squared plus x2 minus x1 squared. Okay, now anything else that I basically can't think of anything else as of now. Yeah, so let's get started. First thing first, we need to form equation. Let's call this A, B, and this point O. We need equation for AB in the form of y equal mx plus c. And we also need, this is step one. We're trying to figure out, okay? I might not call it step one, all right? Don't call it step one. So we need to figure out this equation. We also need equation OP, also in the same format. Once we figure out these two equations, then basically you can see here we need to look for point 0, point O. Look for point O, the coordinate point O. And then what we then do is use distance formula to look for the distance between 0 and O and OP. And that is the process. First thing, we need to look for equation for AB, and then OP, and then point O, and then OP. Okay? All right. Now, the first thing, what we do is to look for, to look for, to look for this equation for AB. We have two coordinate. We have two coordinate is 1, 2, and 5, 4. 1, 2, and 5, 4. 1, 2, 5, and 4. Now, using these two coordinate, we can determine MAB equal 4 minus 2 over 5 minus 1. And then let me work a bit faster. So to simplify it, 2 over 4, and then simplify, we get 1 half. Okay? And then um, after that, what we do is we can then use this formula. This formula. We have one slope which is MAB. We have two coordinates. We just need one of them. Okay? We just need one of them. And my preference is always smaller numbers, so 1, 2 is my go-to. So let me copy this formula. Y minus y1 in my case is 2. M is 1 over 2. X minus x1. X1 is 1. So I stand into this equation. 1 over 2x minus 1 over 2. And then I combine this. I move minus 2 to the other side. And I get y equal 1 over 2x plus 3 over 2. Let me simplify it. Let me factorize it. So 1 over 2 times x plus 3. Essentially, one thing you will realize, this is in the format of this. Okay, so the y-intercept is this, slope is this. Okay, now we have gotten equation for AB. The next one, what we need to do is we need to look for equation of this. And I'm afraid to run out of space, so okay, so we do exactly the same thing. Um, the p coordinate from here, p coordinate is 1, 7. And do we have MOP? We don't, but we can look for it because we know that M1 times M2 equal -1 when they are perpendicular. perpendicular. So MOP times MAB will also be -1. We know that MAB is 1 over 2 equal to MOP would therefore be -2. We use exactly the same formula, this one here. So y equal 7 equal -2 times x minus 1. Do exactly the same, -2x plus 2. Move this to the other side, y equal -2x plus 9. Alright, this is equation OP. So once we figure out this equation, next thing is we need to use these two equations to solve for point 0, not point 0, point 0. Okay, so now we have these two equations. Equation 1 is y equal half x plus 3 over 2, first equation. The second equation is -2x plus 9. So what we can do is I can let these two equations equal because this is y, this is y. So half x plus 3 over 2 equal -2x plus 9. And I combine x's on one side, non-x's on the other side. Okay, so let me copy half x, move across, plus 2x equal. And I copy plus 9, and this move across, I get negative 2 over 3. Combining these two, I get 5 over 2x. Combining these two, I get 15 over 2. Alright, so we can do simplify. So we we multiply the reciprocal of 5 over 2, which is this reciprocal on both sides. X is 3. Alright, and we have two equations. We just need one of them. I will pick 2. 2 y equal -2 times 3 plus 9 equal 3. Alright, so the coordinate for O is 3, 3. This is 3, 3. Okay, and the last bit basically is to use the distance formula, which is this one. So DOP equal um, what is P again? 17 OS 33. Okay, let's get it. So y2, that's minus 3 squared. 1 minus 3 squared. So if you use the calculator, if you were to use the calculator, So square root bracket 7 minus 3 square plus bracket 1 minus 3 square. So that is approximate, oh no, 4.5 units. Okay, so that is example one, which is a long one. All right, radio, let's start to work on example three. So example three is to look for the distance between two parallel lines. Two parallel lines. Line one and line number two. You can see that the M1 is equal to -3. So as M2. And remember the M1 and M2, M1, M2 are equal, that means parallel. Now, let me use math way to show you. So the same formula. Um, so no. So you can see by putting the two equations into math way, you can understand how these two, I would select solve by graphing, see solution. You can see these two. I can't really modify this, alright? But what you can see is basically what you'll be able to see is y, x. There are two lines. Alright. So what we do is I will pick a point. I will pick a point from one of this line. Okay. So what I'll be doing is step one. We have two equations. Y equal minus 3x minus 5. Y equal minus 3x plus 6. There are two equations and I pick this one. Okay. Can you pick the other one? Of course you can. Step two. And then based on this equation, right? Minus 3x minus 5. I would pick a point. Alright. Typically I would pick a point x equals 0 because when you substitute inside to this equation, you automatically find y, and y in this case is -5. Of course, can you look for any other points? You definitely can. But this approach is what I find the most direct. So costs less amount of time. Okay. So basically, 0, -5 is this one, this point, and y equal -3x minus 5 is this line. So we need to go backward, look for this point. This is step number 3. How do we find for the black point? How do we find black point? We need to we need this equation first. This equation. Okay. So We know that m perpendicular times um and this line is r, and this is t. R equal -1. And perpendicular is what we need. MR we know is -3 equal -1. So if we rearrange it, we get 1/3. So we have coordinate, basically, slope is 1/3, coordinate is 0, -5. Using this, we can substitute into this equation. Y minus y1 equal m times x minus x1. Y equal, no, y minus -5 equal 1/3 times x minus 0. So if we rearrange it, we will get y equal 1/3x minus 5. Of course, I skipped some steps, so you need to work on it. All right. So we know that this line equation is this one, and we we know that line t equation is given on this one. So step 4 would be to look for this coordinate by using two equation. Equation number 1 is y equal -3x plus 6. Like equation number 2 is y equal 1/3x minus 5. Set to equation 1 and 2. And then let equation 1 equal to equation 2. -3x plus 6 equal 1/3x minus 5. You combine these two onto the left. You combine these two on the right. So put an equal sign, and when I combine it, I will get -3 and 1/3. I can rewrite as -10/3 x, and move 6 to the other side, -11. Negative cancel out. If I rearrange it, I will get 33/10. That is the x. Y, basically I will reuse equation 1. Equation 1 is this. All right. Y equal -3 times 33/10 plus 6. If we work on it, so 3 times 33 is not -99 plus 6. I can rewrite into a fraction. Okay, 6, I can rewrite 6 into 60/10. And then I can just replace this. The answer will be -39/10. So this coordinate is 33/10, -39/10. Now we know this point. We also know this point. So what we can do is the last step will be step number 5. Step 5. Coordinate number one is 0, -5. Coordinate number two is 33 over 10, -39 over 10. So what we need is df equal square root of x2 minus x1 square plus y2 minus y1 square. It doesn't matter which one is x1. I set this to be x1, y1. Alright? And then, so um, x2 will be -3.9. I decided to use decimal. It will be less writing. -3.9 minus 0 square plus 3 point, oh sorry, make a mistake. Here's x1. X1 should be 3.3 minus 0. Y2 should be -3.9 minus 5. Alright, so if you put it into the calculator, you should get this calculator. Alright, you will get 3.479. I can round it up to 3.5 unit. Okay, and one more thing is you can see here on this equation, we started using this equation, and then when we find the coordinate doesn't change. So this equation and the one that is perpendicular to to it, basically the only changes is the slope. You can see y equal 1 over 3x minus 5. The intercept doesn't change, so the only thing that changes the slope. Hopefully this makes sense, and I have included all the key points, and hopefully it does make sense. Thank you very much for what thank you very much for watching, and I hope you find this useful.